Okay, we are going to discuss midpoint theorem. Today we'll be discussing the proof of the theorem as well, the midpoint theorem, converse of the midpoint theorem. Proof today I'll not be showing you. Okay, I'll just show you what exactly the statement says, and then we can start solving the question. In one go, if I'll give you both the proofs, you will end up getting confused. So today midpoint theorem proof we'll see. Okay, and the converse, just the statement we'll try understanding, and then we'll solve the questions. So yeah, let's start. Here the theorem says very basic line joining midpoint of two sides of a triangle is parallel to the third side. Okay, line joining midpoints of two sides of a triangle is parallel to the third side. Okay, I'll also show you how to prove it's half of the length of the third side. Over there only we'll be able to prove. But actually this is the theorem. Okay, line joining midpoint of two side of a triangle. So if you are having a triangle, let's say a triangle ABC. And if you know the midpoint over here, let me take the same name so that when later on you will see the proof in the book, it will make sense to you. So suppose this is E, this is F. These two are not random point. E and F are the midpoint. E is the midpoint of AB and F is the midpoint of AC. And when you will join it, it's a line segment joining the midpoints, right? Right? Okay, we will be proving this EF is parallel to BC, and we will also prove that EF is half of the length, okay, half of BC. Okay, so here it's given that AE is equals to BE and AF is equals to FC. This much is given over here, and what we will be proving, we'll be proving it's parallel. Okay, meanwhile we will also be able to prove that EF is half of BC. So it can be given in the question that line joining midpoint of two sides of a triangle is parallel to the third side and is half the length of third side. If this much the statement is given, then we need to prove EF is half of BC. Okay, let's prove both of them over here. Meanwhile, see, one extra step when you will write while doing the proof, you will not lose marks. But one less step when you will write, definitely you will end up losing marks, right? So if you will do all of them, even if the half condition you don't have to prove, you can do it. Okay. So this is what the statement says, and that's what we need to prove. First of all, please tell me whether the statement is clear to you or not.
Yes, ma'am.
Yes, ma'am.
Everyone, the statement is clear. See, you are having a triangle, just a random triangle. In this triangle, you know the midpoint of AB and you know the midpoint of AC, and you are joining these two midpoints, and you are getting such a line segment which is parallel to the third side and is half of the length of it. Okay. Now let's see how we'll prove it. Here we need to do one construction, because without doing construction, we cannot say that EF is parallel to BC. Okay. You do anything, you will not be able to prove with this much of like concepts, whatever you have learned so far, you will not be able to prove that these two are parallel with each other without construction. So we need to take the help of construction. Now do you need to learn how we have to do the construction over here? Yes, you need to keep in mind always. Okay, this is how we start. We always start with construction over here. So proof I'll be showing you, please don't note down anything over for now. First try understanding the concept. Here we need to do construction. What we will do, we are going to extend this line segment EF. Okay, we will be extending this line segment EF in such a way that this EF and FD, okay, till D I am stretching, we will be stretching it in such a way that this EF and this FD must be same in length. That's how we are going to do the construction. Okay, listen to me carefully. EF was already there in the triangle. We are just extending it till the point D such that EF and FD are same in length. That's what we have to do as a construction. And then we will be joining this D with C. Making sense?
Yes. Yes, ma'am.
Yes, ma'am.
So let's write the construction. Okay, and joining vertex C with D. Okay, that's it. This much construction we have to do. Okay, again you need to, let's just keep it in your mind that you are supposed to prove that EF is parallel to BC. But let me show you how exactly we'll be doing this proof. So first of all, we'll be doing the construction, which you have to do because there is no other way. After doing the construction, you need to take this two triangle. I'm talking about this orange color triangle and this orange color triangle. Easily you will be able to prove these two are congruent. Now why you will take this two are congruent and all? Okay, because you have to prove parallel, EF parallel to BC. Okay, why we will be taking this two triangle? So see, if you will take this two triangle, easily you will be able to prove parallel condition, which you are exactly, okay, you are supposed to prove. The moment you will prove this two are parallel, I mean these two are congruent with each other, there only you will be able to say the by CPCT this angle and this angle will be same. By CPCT, okay, by CPCT this two angle will be same. After proving this two congruent, we will be able to say angle A over there will be equals to angle C over here. And the moment we are saying these two angles are same, now there comes a concept which says that there are two random line. Okay, that is DC and AB, and there is a line like this, transversal like this. And if this angle and this angle are same, that means this AB and CD are not random line. These two are parallel line. Why? Because alternate interior angles are equal. Yes or no?
Yes, ma'am.
Yes.
Okay. So first of all, you are proving congruent. Due to that, the angles, orange color angle are coming same. And with the help of the angle, you are able to say AB and CD are parallel. Clear so far?
Yes, ma'am.
Yes,
Okay,
ma'am.
now see carefully this condition. AEBE same, right? Right? And from congruency, you will also be getting that this side and this side are equal. From congruency, CPCT, okay, you will be getting AECD same. Okay, from congruency, you will be getting AECD same. but it was given that AEBE same. So from there you will be able to say BECD same. Yes or no?
Yes. Yes, ma'am.
In sense, okay, this BE and this CD, easily you will be able to say it's equal in length. I will show you how. Okay, easily you will be able to say these two are equal in length as well. So first of all, you are saying this line parallel. Now you are saying this length same, and hence it will become a parallelogram. And then the moment you will say it's a parallelogram, you are done with the proof. This proof is done. EF is parallel to BC. Okay, let me summarize everything because so many things I told you in one go. So let me summarize everything. Don't, okay, note down anything for now. Try understanding what is the, like, why we are going to use this approach. So first of all, a triangle was given where we just know that E and F are the midpoint. We have extended it, okay, by maintaining EF and FD same in length. Now we are proving that this triangle AEF, it's congruent to the other triangle CFD. These two triangle are congruent. Easily you will be able to prove. Making sense? Making sense?
Yes, ma'am.
Here you will be able to say that angle A over here is equals to angle C over there. And also you will be able to, the length AE over here is equals to the length, wait, let me check. Have I written the name correctly? Yeah, this is the name. Okay, while proving the congruency we will see the name, but this two congruent will be proving, and by CPCT we'll be getting this condition, and by CPCT we will be getting this condition. So far, is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, I'm writing in bold that what exactly we need to do here. We need to prove this to our parallel. Okay, we will not forget that. While doing everything, we will keep in mind that we are supposed to prove that EF and BC are parallel. Okay, now from this angle A, angle C same, from here, can we say that AB it's parallel to CD? Yes or no? AB,
Yes, ma'am.
CD. There is a transversal, this angle and this angle same. So from there we are able to say ABCD are not random line, these two are parallel line because alternate interior angle are same. Clear?
Yes, ma'am.
Okay, so we are having one condition that AB and CD are parallel with each other. Now we will also be able to prove that this length, okay, the length BE and the length CD are equal. See, easily we will be able to prove that this length BE and this length CD are equal. Okay, I mean, if AB and CD are parallel with each other, we can say a part of it BE that will also parallel with CD. Yes or no?
Yes, ma'am.
If completely AB and CD are parallel, then a part of AB and completely CD still will be parallel. Yes or no?
Yes, ma'am.
Yes.
Okay, if the complete length is parallel with this one, then even if you will decrease the length, still it will be parallel. Yes or no?
Yes.
Yes, ma'am.
Okay, I was telling this concept in the last class that if you are having a line and if you are having another line, and if these two are parallel with each other, if you will decrease the first line's length, still both will be parallel. Okay, even if you will extend any one of the line and will keep on extending, still both will be parallel. Okay, so if AB and CD are parallel, from there we are able to say that BE and CD will be parallel, and easily we will be able to prove that BE and CD are equal also. Let me show you how. You already know, it was given to you that AE is equals to BE, right?
Yes, ma'am.
Yes, ma'am.
Okay, and just now you have written this one. Can you see the blue highlighted part?
Yes.
A, B same.
Yes, ma'am.
A, C, D same by CPCT. Okay, so from here, can we say that B, E, C, D same? Yes or no?
Yes, ma'am.
Okay, if B, E, C, D parallel and B, E, C, D equal, it has to be a parallelogram. Yes or no? Because there is no other
Yes, ma'am.
quadrilateral where opposite side. Yes, only one pair. Opposite sides are parallel as well as equal as well. Okay, in trapezium, opposite sides are parallel. But we never say it's equal. Yes or no?
Yes, ma'am.
Okay, you have
Yes,
seen such question where equal side used to be given, but legs were equal, not the bases, the parallel side, right? So
yes,
side which are parallel and is equal as well. Okay, it only happens in parallelogram, even though we don't know, have any information regarding the next, okay, other pair of sides and all. Still, if only this two purple one, it's this BE and CD, if these two are parallel as well as equal, it has to be a parallelogram. Confidently we can write over here that BE is parallel to CD and BE is equals to CD. That means BECD, okay, I mean BEDC is a parallelogram. Making sense?
yes,
Okay,
yes,
and
ma'am.
initially with bold I have written over there that what exactly you have to prove. You are supposed to prove this one, this, the green highlighted part. And can you see we are done with the proof? Can you see?
Yes, ma'am.
Yes, ma'am.
Okay, so please don't memorizing like the steps, try understanding what we are doing. Yes, construction you have to keep in mind. Again, I'll be telling everything from the beginning, and you tell me if you are having any doubt anywhere. And once you are clear, once your concept is clear, once you are able to do it all by yourself in the rough space quickly, okay, within just 2 minutes, then I'll be doing it in the fair portion. Okay, then you can note it down just for the reference, that anytime you have to revise, you can just go back to it. Otherwise, in today's class only, make sure that midpoint theorem you will be able to prove after the class. Okay, without even revising it. Okay, let's do it again. So we are having a triangle. Again, you are not going to note down anything. Please don't note it down. We are having a triangle ABC. We were having the midpoint E. We were having the midpoint F. Okay, and we were supposed to prove that EF is parallel to BC. We were supposed to show that EF is parallel to BC, and we were not able to do so by doing, like, by taking any triangle, the upper one or maybe the complete one, by doing anything we were not able to do. So for that we have done the construction. We have extended this EF till the point D, and we have joined this D with C. Okay, in construction we made sure that EF and FD are same in length. And due to this construction, now easily we will be able to prove this triangle AEF, it's congruent with triangle CDF. Easily we will be able to prove, and from there we'll be getting angle A is equals to angle C, and angle I mean side AE is equals to side CD. This angle A and angle C will help you declaring that now AB is completely parallel to CD. And since AB completely it's parallel to CD, this BE will also be parallel to CD. We are almost there. We are almost there. We are almost about to say that this is nothing but just a parallelogram, and hence we are done with the proof. Okay, we have already declared that this BE and this CD are parallel. Now we just need to say these two are equal also, and easily we will be able to say that these two are equal, because one given condition was there that E is the midpoint. So AE and BE are equal. AEBE equal, and just now by CPCT we have obtained such a condition which is helping us saying that BECD same in length. If BECD parallel and BECD equal, that means it has to be a parallelogram. This BCDE is a parallelogram, and hence we are done with the proof. Is it clear?
Yes.
Yes, ma'am. Yes, ma'am.
Okay, if I'll give you 2 minutes, will you be able to do it in this manner in the rough portion, everybody, without seeing anything?
Yes.
Yes, please
Yes,
confirm.
ma'am.
Rishikesh, will you be able to do?
Yes, ma'am.
Yes, Lokya, will you be able to do?
Yes, ma'am.
Afia?
Yes, ma'am.
Yes, Chakrika?
Yes, ma'am.
Gauri?
Yes, ma'am.
Rayan?
Yes, ma'am.
Rayan, are you there?
Yes, ma'am.
Tanisha?
Yes, ma'am.
Okay, let's get back to the proof, and now you can write the steps. However, I still have not shown you how to show that this is half in length. Easily you will be able to do that also. I'll be showing in the fair portion. Okay, so construction we had already written. Now let's do the proof. I'm just this upper portion I have drawn the triangle and the extended quadrilateral as well, but I'm drawing it again over here just for reference. Okay, it was EF. We are going to take this two triangle AEF, and you can take it anyway. Okay, FTC, whatever. Easily, like you will be able to say that we know AF and FC are same. Okay, as it was given. Okay, F is the midpoint. Directly you can write it is given. Making sense?
Yes, ma'am.
Okay, you know that this AF and FC are equal in length. Then you know vertically opposite angle over here and the vertically opposite angle, another one. So you will be able to say angle F over here is equals to angle F over there. And just now in your construction, you have only assumed that these two are equal in length. For doing this proof only, we have taken the assumption. So we will say EF and DE, DF are equal, okay, by construction. And we are done with the congruency. We can say these two triangle are congruent by SAS, right? Right.
Yes, ma'am.
Yes, ma'am.
Okay, let's move. So these two triangles are congruent with each other. Now parallel we need to prove EF and BC. So from here CPCT is going to help you. You will be able to say that, which implies that angle A is equals to angle C. You can mark it as a equation 1, because just now we are going to say by using 1, AB and CD are parallel. So you can mark it. And then we can also say that from this congruency, we are also getting AE length is equals to CD. Okay, again by CPCT, you can mark it as a equation number 2, because just now we are going to use this data. Now we will say from 1, let's write properly that AB and CD are two lines and AC is transversal such that angle A over here, okay, you can write EAF is equals to DCF. I'm just going to from 1. Therefore, okay, which is, it's a pair of alternate interior angle as well. Which implies that AB and CD must be parallel. Okay, and from here only we can say that BE and CD also will be parallel. Clear so far? The steps.
Yes, ma'am.
Yes, ma'am.
Okay, parallel we have shown. Now equal also, equality sign. Like these two sides are equal in length as well. That's what we'll be showing. And easily we will be able to show that also. We will say we know A is equals to BE. Okay, as E is the midpoint of AB. And from equation number 2, we can say AE is equals to CD from 2. Therefore, BECD will be equal. Okay. You can mark this one as a condition number 3. Okay, and this one as a 4. From 3 and 4, we can declare that this is nothing but just a parallelogram where opposite sides are parallel as well as equal. Hence, it has to be a parallelogram. Okay, so from 3 and 4, the name was BCDE. Okay, BCDE is a parallelogram. Therefore, the parallel condition which we are supposed to prove will be writing over here, and we are done. So we were supposed to prove that in this triangle, EF is parallel to BC, right? If it's a parallelogram, then EF, okay, actually it's a parallelogram, then DE and BC are parallel. Okay, this completely, this side DE and this BC, that is parallel as well as equal. But if that is parallel, then we can say EF will also be parallel, right? Right?
Yes, ma'am. Yes.
And we are done with the proof. Okay, half of the length, that also will be showing just now. Now we will say that the complete and the complete length, okay, DE and BC will be same because it's a parallelogram. Opposite sides are parallel as well as equal. Yes or no? Right? DE and BC has to be equal in length, right? Okay, if DE and BC are equal in length, can I write this DE as a, okay, EF plus DF? Yes or no?
Yes, ma'am.
Okay, EF plus DF, that is equals to BC. But we have done the construction in such a way that we have maintained this EFDF same, right? While doing the construction only, we have maintained this two lengths same, EFDF, right? So we will
Yes.
use this condition that these two are equal, EFDF are same. So at the place of DF, we can write EF. Here we will write by construction. Okay, that is equals to BC. And we are done. Can you see? The length EF is half of BC. We are done with the proof that it is half of the length also. We'll be able to say 2 times EF is equals to BC. That means EF is equals to half of BC. Clear?
Yes. Yes, ma'am.
Okay, we are done with the proof over here. EF parallel to BC, that also we are done with the proof. And this is the complete proof of midpoint theorem. Okay, which is really, so many steps are involved, so many concepts are involved, but yes, practice is required. Then only you will be able to prove it in your exam. Yes, have you noted down the previous part, everyone? Shall I scroll up or down where like you are? Please let me know. See, the theorem starts from here. Theorem is written on the screen, then the given portion and the showing part is written. Then we have done the construction. Shall I scroll down?
Yes.
Yes. So here we have done the construction and then we started doing the proof. You can see construction is written. After that, we started doing the proof. We have taken the triangle. We have proved these two congruent. Yes, please note it down. And yeah, please let me know if you have already noted it. Yes. Tanisha, Afia, Gauri, Rayan, are you done? Have you noted it
Yes, ma'am.
already? Are
Yes,
you
ma'am.
done? Okay, let's move. Completely you have noted? Is it okay?
Yes.
Okay, then you are done, right? Everyone, you are done, right?
Yes.
Okay, let's move. So yeah, as I said, midpoint theorem you will be discussing in today's class, and we will be discussing one more part, that is the converse of midpoint theorem, because this two theorem we need to use for doing the proof. However, the proof of converse today I'll not be showing you. So converse of midpoint theorem says that if you are having a triangle, okay, again ABC, and if you know there is a midpoint over here, that means E is the midpoint. if you are having a triangle and if E is the midpoint, then the line segment which is passing through E and is parallel to BC. Okay, I'm drawing a line from E, but carefully I'm drawing and just maintaining it parallel to BC. And the line segment, it's going and going and going and going and going and going and touching AC at F. Now, two things I maintained. Okay, E is the midpoint and the line is parallel. E is the midpoint and the line is parallel. Only we know two things. What is given over here? It is given over here that AE is equals to BE and EF, it's parallel to BC. These two conditions are given. And what we are supposed to show, we have to prove that F is the midpoint also. Making sense?
Yes.
Making sense?
Yes, ma'am.
Okay,
Yes,
that's
ma'am.
the converse of the midpoint theorem. Midpoint theorem was midpoint joining one midpoint with the another midpoint. The line segment is parallel to the third side and is half of the length of the third side. Converse of the midpoint theorem is if you are taking one of the midpoint and using the parallel condition, then automatically the other midpoint is coming. Okay, let's solve the questions now. Exercise 8.2, first question. I'm writing over here. I'm drawing the figure which is given along with the question. Okay, three parts are there which we are supposed to prove over here. The first one is SR is parallel to AC and SR is equals to half of AC. Next is PQ and SR same in length. And the third part is PQRS is a parallelogram. Figure looks like this. Yeah. Actually, this is the figure which is given along with the question. Okay, I have not drawn the figure. So regarding the figure, we will not have any discussion. ABCD is a quadrilateral. Just look at the figure. ABCD is quadrilateral over here, in which PQRS are the midpoint of the side AB, BC, CD, DA. So this PQRS, okay, which I have not marked so far. This is P, this is Q, this is R, and this is S. This PQRS are not any random point. These are the midpoint. Okay. P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, and S is the midpoint of AD. Making sense?
Yes, ma'am.
Okay, and AC is the diagonal. Now with this much of information, prove that SR is parallel to AC. It's really simple. You just need to use midpoint theorem. Okay, the first part, SR parallel to AC, SR parallel to AC. See, if you will take triangle, this one, you will be able to say that in this purple one, okay, purple color triangle, already we know S is the midpoint and R is the midpoint. I'm not saying, it's written in the question itself that S is the midpoint of AD and R is the midpoint of CD. So if S and R is the midpoint, then line segment joining this SR must be parallel to the third side. Yes or no? By using midpoint theorem, right?
Yes.
Yes, ma'am.
Okay, and it will be half of the length of the third side. Clear? Do we need to show steps and all over here? Nothing we have to do, just in bracket by using midpoint theorem. We will say in triangle ADC, okay, S is midpoint of AD, R is midpoint of CD. Therefore, SR must be parallel to AC, okay, by using midpoint theorem. We are done with the proof. We can also, from here only we'll be able to say that SR is half of the length of AC. And we are done with the first part. Is it clear to all of you? Is it that simple? Yes, it's that simple. Most of the questions over here are that simple. Yes, the proof of the midpoint theorem, that is not simple. Clear?
Yes.
Okay, because we are going to use that theorem in most of the questions over here. So yes, okay, it's worth just practicing enough the proof, because from here, if you can expect initially like one question which is really important, midpoint theorem proof or the converse of the midpoint theorem proof, definitely can come in exam. It's that important. Okay, so please do the proof properly, otherwise questions are really easy. First part we are done. Now we'll be doing the second part, but before proceeding, anyone having any doubt? No? Okay, let's take the next one. PQ is equals to SR. So we will say in the other triangle. For now, we can mark it equation number 1. Okay, this one as a equation number 1 and this one as a equation number 2. Okay, now we are going to take another triangle. Similarly, exactly same way, we will be taking another triangle. I'm talking about triangle this. ACB. In this triangle, we will say the same thing. P is the midpoint, Q is the midpoint. So PQ must be parallel to AC. Clear?
Yes, ma'am.
Okay, and PQ must be half of the length of the AC. Okay, let's do. So we will say in triangle ABC, okay, P is the midpoint of AB, Q is the midpoint of BC. Okay, hence PQ is parallel to AC, and PQ it's half of the length of AC. Okay, again by midpoint theorem. You can mark it equation number 3. You can mark it equation number 4. Now focus on equation number 2 and 4. 2 and 4. Can we say SR and PQ are same in length? Can we? Equation number 2 says that SR is equals to half of AC. And equation number 4 says that PQ is equals to half of AC. That means both are same. Both are half of AC. Yes or no?
Yes, ma'am.
Making sense? This one highlighted part.
Yes, ma'am.
Okay, SR is half of AC, PQ is half of AC. So from 2 and 4, we can say PQ, SR both are same in length. Okay, we are done with the second part proof as well. Clear?
Yes.
Anyone having any doubts so far?
Ma'am, can I explain again?
See the highlighted part. Uh, Before the shall I explain from the beginning?
For the second part one that you were just
Okay.
explaining.
Okay, I have taken the ABC triangle, and just like the purple triangle, here also we got the parallel condition and the equal condition. Okay, exactly like the previous one. That PQ, the line segment, is parallel to the third side of the triangle and is half of the length. Now this two highlighted part, when you will see carefully, you forget about the figure and all. Just see the highlighted part. SR is half of AC and PQ is half of AC. That means both are same, right?
Yes.
Yes. Is it making sense, Gauri?
Yes, ma'am.
Okay. So from 2 and 4, we are able to say that SR and PQ must be same. We are not seeing the figure. We are just seeing this highlighted part. And we are able to say these two are same. Okay. Second part proof done. Now we have to do the third part. So see how we have approached the second part. Okay. We have taken this sky triangle by ourselves. Okay, just to land at the condition which we are supposed to prove. Clear?
Yes.
Now the third part says that show that PQRS is a parallelogram. So far, by seeing this condition 1, that SR is parallel to AC, and this condition number 3, PQ is parallel to AC. If these two are parallel to the same line, that means these two must be parallel with each other, right?
Yes.
Okay, SR is parallel to AC and PQ is parallel to AC. That means SR, PQ, AC all are parallel with each other, right? Right? And just now you have learned that this much condition is enough to say it's a parallelogram if opposite sides are equal in length and is parallel also. These two sides which you said in part 2 are equal in length. Okay, this equation number 1 and equation number 3 is going to help you to say these two are parallel also. It's not just equal, it's parallel as well. Making sense? By 1 and 3.
Yes, ma'am.
Yes, ma'am.
If it's parallel also and equal also, it has to be a parallelogram, right?
Yes, ma'am.
Yes.
Right? Which has to be parallelogram? The third part, that is PQRS has to be a parallelogram. Making sense?
Yes.
Yes, ma'am.
Okay, we are done with the proof. We'll be just writing one more step, that by 1 and 3, SR is parallel to PQ. Okay, then from part 2, which we have already proved, and this condition which we are having in hand, PQRS is a parallelogram, because no other quadrilateral have opposite side. Only one of the pair, okay, only one opposite side pair are parallel. As well as equal, it has to be a parallelogram only. Clear?
Yes.
From 1 and 3, okay, SR, it's parallel to PQ, and we know PQ is equals to SR, already proved. In part 2. Therefore, PQRS is a parallelogram, and we are done. Clear so far to everybody?
Yes, ma'am.
Okay, so yes, today I'm keeping this much over here. I'll be taking the next questions in the next class, but your task is to make sure that you are not going to forget the proof of midpoint theorem. And these questions which we are doing over here, practice it by yourself. Okay, mainly proof of midpoint theorem, until or unless you will say that anytime I'll ask you midpoint theorem, just tell me the proof, you will be able to tell me the proof. If you will say like that, then only I'll explain the converse of the midpoint theorem. Okay.
Okay, ma'am.
Yes, I'm keeping this much over here. Thank you, everyone. Take care of yourself.
Thank you.